Show how the principle of superposition of waves can be used to explain the formation of two source interference fringes. Explain. Waves from two sources can overlap and interfere. The resultant displacement at any point, at any instant, is the vector sum of the individual displacements caused by each wave. At position where the two waves arrive in phase, constructive interference occur, resulting in high intensity fringes. At positions where the two waves arrive out of phase, destructive interference occur, resulting in zero intensity fringes. Two source interference fringes using light can only be obtained if light from the two sources is coherent. Explain the meaning of the term coherent. The two sources maintain a constant phase difference respect to each other. That is what coherent means. Explain why, in practice, interference fringes can be seen only if light from a single source is split into two. Light from two independent sources are not coherent, and the phase difference between them changes rapidly and randomly. Thus, the resultant fringe pattern would also change rapidly, too fast for the human eye to follow. By using light from a narrow region of a single source and splitting the light into two, we have effectively two coherent sources which will produce stable interference fringes that can be seen. Coherent monochromatic light from two narrow slits a distance 0.38 mm apart causes an interference pattern on the screen 1.2 meters from the slits as illustrated in the figure. The distance from the 6 bright fringe on one side of the pattern to the 6 bright fringe on the other side of the pattern is found to be 26 mm. Calculate the wavelength of the monochromatic light. The wavelength is given by this relationship. So we have a wavelength of 686 nanometers. State the experimental advantage gained by determining the fringe width in the way that was used in part 3. Using the spacing between 12 fringes reduces the percentage uncertainty in the measurement of the fringe width. Another way of obtaining fringes similar to those described in part 3 is illustrated in the figure. A single slit is viewed both directly and by refraction from a mirror surface. Explain why this system produces a fringe pattern. Now, light reaches the eye through two paths, one directly and two after reflection of the mirror. They act like two sources of light which can interfere with each other to produce interference pattern.